This lesson, your students begin an engineering challenge. Their mission? To develop a working prototype of a prosthetic hand. In this video, we'll show you how to support students as they draw on and develop their engineering design practices. At grade 6, students are expected to define the criteria and constraints of a design problem themselves and take into account relevant scientific principles, such as an understanding of the systems and subsystems involved in moving a human hand, the way the muscular system and skeletal system work together to produce movement will provide students with inspiration for their own biotech designs. You'll start by introducing the challenge with a video, which outlines the basic requirements.
Losing an arm or leg is a life-changing experience, but for many people, artificial limbs or prosthetics make a huge difference.
The task criteria and constraints are detailed further in a letter from Biotech Systems Worldwide, including restrictions on the materials they'll be able to use and the budget. But before they jump into designing prototypes, your students need to better understand how the human hand works.
So even simple movements use a complex system of bones, muscles, and tendons, all working together. This allows people to use their hands very precisely for all kinds of different tasks.
Okay, how do the parts of the hand work together as a subsystem?
The tendons are connected to the bones, and then the tendons are also connected to the muscle. So when the muscle pulls, the finger moves back.
Very good, excellent. Get the teams to investigate different ways of lifting and holding water bottles. Their observations will help them come up with initial ideas about how to design their prototype. What part of your hand, or how many fingers are you using to pick up this water bottle?
You're using all 5 of your fingers and your palm.
Are you able to pick it up with 2 fingers? And is that as secure as the full hand?
No.
Does that mean that you wouldn't be able to pick it up though?
No, you could still pick it up.
You can still complete the task, even though it's not as secure. I want you guys to think about your design and how many fingers you're going to use to pick up your water bottle. Students should be able to explain their ideas, using what they know about the human hand as evidence. How are you going to lift your bottle, Riley?
I'm going to pinch it with 3 fingers like this.
Okay, and what materials are you going to use?
I'm going to use the straws to represent the bones, and then rubber bands to use as the tendons, because those will stretch.
In the next lesson, students use these ideas to come up with more detailed designs. If anyone's struggling to find a suitable solution, don't worry. There's a teacher handout you can refer to with details of 5 potential designs, plus guiding questions you can use to assist students. In later lessons, the teams will build, test, and revise their prototypes to create their final design solutions. But it all starts here, with investigating and defining the problem, just like biotech engineers do in the real world.
Oh my gosh.